Two of the most baffling events ever shot by NASA's own cameras involving UFOs in space. These seemingly enormous discs videotaped near a failed scientific testing device, and this one flying perilously close to the occupied International Space Station, could prove alien spacecraft are monitoring our experiments from very close range. February 25th, 1996. 100 miles above Africa, an experimental satellite system attached to a 12-mile-long electricity-conducting tether suddenly breaks. Within moments, the satellite drifts almost 100 miles away. Nitrogen gas gathers around the tether, effectively turning it into a gigantic fluorescent light in space. Incredibly, it seems to attract some strange company.
When I saw the tape, I realized that I was looking at very exciting, incredible footage that has never before been seen by the public.
David Sarita, an avid UFO researcher and video analyst, has been looking into UFOs documented by NASA cameras for many years. And he believes this incident, which has since become known to leading experts as the Tether Incident, may prove aliens exist and are studying us.
You see a swarm of what may be UFOs flying around it, and then we see the cameras zoom in on these objects, and we see giant discs passing behind this tether.
Yet the astronauts involved in the test seem to have a more mundane explanation.
There's a little bit of debris that kind of flies with us.
But is it really mere debris, as NASA often claims, when looking at alleged UFOs in space? Watch what happens when the cameras zoom in.
What we're seeing on the screen here appears very small, but if you blew this up, you would see that these objects are enormous in size. This UFO here, I measured approximately 2 to 3 miles in diameter against the 12-mile length of the tether. If it's further behind the tether than I think, it could be much larger.
The potential size of these UFOs is clearly mind-boggling, and, according to Sarita, so is the advanced technology behind them. Would a piece of space junk pulsate in a regular pattern as we see here?
This spiral, to me, suggests a gravity wave that is stronger than light. This, to me, is proof, in quantum physics, that these UFOs are utilizing very advanced forms of gravity energy and zero-point energy.
Whatever kind of detectable, pulsating power source was captured in this compelling UFO footage, no one has been able to explain or identify this mysterious, undeniable strobing spacecraft that flew extremely close to the International Space Station in 1999. Though none of the scientists conducting experiments aboard the space station publicly acknowledged what should have been a truly alarming incident, this rarely seen video, recorded live by a dedicated NASA downlink observer, is considered by top experts to be one of the most puzzling NASA UFO videos ever shown. Where did this craft originate? What is its purpose? And what might analysis of this strobing light reveal? While NASA remains tight-lipped, UFO investigators maintain that the controversy over recorded events like these led NASA to stop live broadcasts during subsequent missions.
On February 25, 1996, on Space Shuttle mission number STS-75, NASA launched a possible breakthrough energy technology experiment. They launched a 12-mile-long electrical conductor cable called an electrodynamic tether, designed to collect high-energy electrons in the Earth's ionosphere and magnetic fields. The motion of the conductor tether across the Earth's magnetic fields induces a voltage along the 12-mile length of the tether. Utilizing estimates in the charge densities of the Earth's magnetic fields and the ionosphere, the voltage produced is expected to be up to several hundred volts per kilometer. If successful, the experiment could produce a lot of electrical power. If additional power is driven along the tether in the opposite direction to that which it normally wants to flow, the tether, in theory, could push, creating propulsion against the Earth's gravity to raise the shuttle's orbit. The advantage to this revolutionary technology in propulsion is that it does not require any rocket fuel. If successful, electrodynamic tethers could prove a way to greatly reduce the cost of in-space propulsion. For example, the International Space Station could keep itself in orbit, saving nearly $2 billion in orbital reboost rocket fuel for every 10 years of the station's operations. But on February 25th, After the 12-mile tether began producing electricity, an unexpected overload of electrical energy fluctuating between 2 and 10 times that predicted due to inaccurate estimates in the electrical charge of the Earth's magnetic fields, ionosphere, and possibly space radiation, fried the tether conductor cable and it broke, severing it from the space shuttle.
So the tether has broken at the boom. The tether has broken and is going away from us. Get it on the TV, Claude. Please get it on the TV. The tether has broken.
Copy.
Columbia and the satellite now 77 nautical miles apart. Again, that call reporting that the crew can see the tether and see the satellite. That it's beautiful. This view showing the satellite. Again, just moving into sunrise. 81 nautical miles now from Columbia.
Guys getting the image?
Franklin, we see a long line, a couple of star-like things, and a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angle. So there's a lot of stray light, and it's getting washed out quickly, but Claude is trying to do a quick, good job here adjusting the cameras.
Copy that.
In that description by the crew, this is the tether in the satellite with approximately 12 miles of tether still attached to it. Columbia and the satellite now just passing over the west coast of northern Africa. The two spacecraft now 90 nautical miles apart. Controllers for the satellite did have communications with it during the close pass between Columbia and the satellite.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
Satellite now 100 nautical miles.
Charlie, completely unzoomed, and you see the full extent of the tether. I tried to adjust the focus, but I can't get better than that.
Okay, Claude. Thank you.
I'm going to zoom in now.